Hey everybody, welcome back to Info 3370, studying social inequality with data science. In our recent classes, we've talked about social mobility as a measure of economic opportunity, and we connected social mobility to a prediction task. How well can we predict the ultimate socioeconomic outcomes for a given child as a function of characteristics of the family into which they were born? We discussed a very particular prediction task using data from the panel study of income dynamics. And at the end of the last class, we talked about how you can download these data from OpenICPSR. So in preparation for what we'll do today, I'll trust that you've downloaded forstudents.zip. I'll also trust that you have not downloaded forinstructors.zip, which contains the outcomes we're trying to predict. That file's on here so that other classes in the future could reuse our prediction task. But it'd be no fun if you look at the outcomes without doing any prediction yourself, so I'm just trusting you to focus on forstudents.zip and let the instructors use forinstructors.zip. This web page introduces an example submission with ordinary least squares. So there are 4 steps. First, we're going to load the data into R. Then we'll learn a prediction function in the learning set. We'll then predict for the new cases in the holdout set. And finally, we'll prepare and upload our submission to a Google form gotten ready for this particular class. So the first step is to load the data. So here I'm going to copy this R code. I'm going to go over here in RStudio and create a new R script. Instead of R Markdown, we're going to use an R script for this file, both to practice a different way of using R, and because an R script is good when you're not producing a report, but you're just producing some code that you want to produce an outcome that you're going to save to your computer and upload elsewhere. So I'll go ahead and paste in this code here. This code is going to assume that you have the data files within the working directory where R is working. So here I have, when I downloaded forstudents, these are the files that I got. I have holdout public and learning.csv. So I'm going to go ahead and note where these files are located by getting info about them, copying this working directory, and then at the top of my code, setting my working directory to that place. Okay, I'm loading tidyverse, so we have the functions that we always use in R. Then I'm going to load the learning set and load holdout public. So what's in these data sets? We can see here that learning contains identifiers for the grandparent, parent, and child, and also some background variables like race, the child's sex, and then a series of additional predictors. Here we have the education of the grandparent, parent, and child, and then we have the log income of the grandparent, parent, and child. This is the outcome that we're trying to predict, is G3 log income. We could look a little bit at its distribution here. By summarizing learning $G3 log income. So it ranges from 8.5 to 13. And if you exponentiated that, you could see what those dollar values actually are. Okay, so we've got the data loaded. We just talked about the learning set. We haven't talked yet about the holdout set. So when we look at the holdout set, it looks just like the learning set. It's for a different set of cases. So you see that case 1 was in the learning set, case 2 is in the holdout set. The other difference is that the child's log income realized as an adult is NA for all cases in the holdout set, whereas it has valid values for all cases in the learning set. This is because of how we're going to use these data sets. As discussed before, we're going to learn a predictive model in the learning set, then we're going to predict these missing outcomes in the holdout set, and the predictive model that we build will be evaluated based on how well it performs at predicting those outcomes. So we've now loaded the data. We are next going to learn a prediction function. So here I'm going to copy the code from this chunk of the website. So what we're doing here, this is our first linear model in this entire class. We're about to take a model, store it in a new object called fit. This object is going to be an LM object, which is a linear model, where we call the model with a model formula. That model formula has an outcome, the grandchild's log income, and 2 predictors, the grandparent's log income and the parent's log income. We also tell R with the data argument where these variables exist. So we're going to look for these variables in the data set learning. So let's go ahead and run this code here, and we get a fitted model object. If you type summary fit, you'll get some information about that object. So here we see there are regression coefficients, standard errors, and p-values. So we can see that for each unit increase in grandparents' log income, respondents' log income rises by 0.13, and for each unit increase in parents' log income, it rises by 0.49. Of course, these coefficients are a little bit hard to interpret because this is the change for a change in parents' log income holding constant grandparents' log income under a linear additive model. But for now, we can just think of this as a prediction function. If you wanted to predict the kid's log income, you would take 0.13 times the grandparents' log income plus 0.49 times the parents' log income plus this intercept term, and that would be your predicted value. So given this model, our next step is to predict for new cases. So coming over here to the website, we have some example code. This example code creates a new object, fitted. And this object is going to begin with the holdout public data set, and then it's going to mutate to change the variable G3 log income. Recall that in holdout public, this variable is currently NA for all cases. We're replacing those NAs with new values. In particular, we're replacing with the predicted values that come by calling the predict function on the fit object, so this model fit object, with a new data set, holdout public. So what this call says is take that new data set, take the predictor values in that data set and apply the coefficients from fit to them to make predicted values. Store those predicted values in the variable G3 log income. So if we do this, we can now look at our fitted data set, and now where holdout public had missing values for the outcome, the now fitted data set has valid values for the outcome. So that's great. We first learned a prediction model in the learning set, and then we predicted in the holdout set. The last step here is to prepare the submission. So when you upload predictions to our website, we don't really want all the variables because that's a lot of extra storage space. We really just want the G3 ID, which identifies each unique case in the data set, and the predicted value G3 log income. So we can prepare our submission, and we can do that by creating a new object for submission, which is that fitted object with only those two columns selected. So if we look at that, we have the identifier and the predicted value of the outcome. Then we're going to save those predictions as a CSV, a comma-separated values file. So save the predictions. The write CSV function takes as arguments the object to be written and then the file name where we're going to write them. So if I run this line and then I come back to my working directory, I see that I now have example.csv right here. The other thing we're going to do is save our R file. And we're going to save this in the same place where we've been working and give it the same name as our saved prediction function. Here I'm calling these example CSV and example R. If you're working with a group, you should come up with some name for your group to identify yourselves, because if your predictions are the best in the class, we're going to identify you by the name of the file that you upload. So pick a fun name, one that you'll recognize that if we say that you have the best predictions, you'll be able to claim it and tell us that that is you. So here we've got our reproducible code that produces the predictions, and we have our predictions in that CSV file. Next, you'll go to the submission site. There's a link here on the course website, and when you go there, you get submissions for the PSI prediction exercise. There's some instructions that tell you what we've just done, and then places to upload stuff. So you'll upload your CSV file, upload your R file, then you'll tell us a little bit about what you did to make these predictions. So for example, we built an OLS model to predict the outcome as an additive function of parent and grandparent income. You might compose this in another file on your computer so that you have it in case you want to modify your submission and resubmit, and then you should paste that in here and go from there. And lastly, and importantly, pick some group member to have an email address for a contact and give us your email address here. This is good because we suspect there are going to be issues with the submissions. Maybe we go to download them and it's not in the format we expect. And over the course of this project, we are going to work with you to help you get the submissions uploaded in a format that we can use. And so that's about it for how to submit. If you want to try it now, go ahead and try it. There's no limit on the number of submissions. Our plan is to take the final submission from each group before we close the exercise as your official submission. So along the way, you should feel free to submit as many times as you want. And we're looking forward to seeing what you come up with. Some things you might try at first would be to fit a linear model with a different set of predictors. Perhaps you add like race or sex into the model here. You might want to add some interaction terms to the model. And soon we're going to talk about how to use sample splitting to pick a good model. And then we're going to talk about several machine learning estimators that you might want to consider. So that's what's coming next.